With me. Baby shark, da 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 da, baby shark, da 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 da, baby shark, da 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 da, baby shark. Mommy shark, da 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 da, mommy shark, da 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 da, mommy shark, da 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 da, mommy shark. No, we're singing. Daddy shark, da 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 da, daddy shark, da 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 da, daddy shark, da 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 da, daddy shark. Devin.
Yes.
Pay attention.
Yes, sir.
What's after daddy shark? Wait, grandpa or grandma? Grandma shark, grandma shark, grandma shark, grandma shark. Oh. Oh. Grandpa shark, grandpa shark, grandpa shark, grandpa shark. Ooh, 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 ooh. Sorry. Oh, here we go. Let's do some math, shall we? Here we go. Okay, 190 degrees. We're basically supposed to draw an angle where you have this. We're going to draw an angle. You guys know angles? Yeah. Okay, angles look like this. What, Celeste? What are you talking about? We're doing math. What are you talking about, Celeste? Celeste, what's up? All right. Anyhow, this is an angle, right? Angle, angle, right? You guys know what an angle is, right? And we can measure the angle by how big it is. I don't know. That's over 90 degrees, so let's guess that that's like a 100-degree angle. So this, I want you to estimate, where would 190 degrees be? Would it be here, 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 or here? Quadrant 1, 2, 3, or 4. Quadrant 1, quadrant 2, quadrant 3, or quadrant 4. Just joking. Feels like this. Quadrant 4. Which one? Quadrant 1, 2, 3, or 4. Where's it going to be? 3. Because it's got to be bigger than 180. Be a little bit bigger than 180. So we'd estimate it to be like so. You're going to draw like this. And then you're going to go like this to show how big it is. 190 degrees. Okay, now guess what? How the heck do we get negative 45 degrees? How do we get negative 45 degrees? Alyssa, go to your seat. Don't worry about it. Sit down, please. How do we get negative 45 degrees? If this way is positive, then this way will be negative. And negative 45 will be this way. It'll be like that, negative 45 degrees. And that's how you would answer that. We are going to be combining our right triangle trigonometry with angle measurements. And it's all going to come together, okay? So this is the introduction of our trigonometry phase, okay? So negative 45, 190 degrees. Boom, there's your answer. Today we're going to talk about angles and radian measures. Okay, angles and radian measures. That's our topic. Angles and radian measures. What's going on? Did you guys just finish the test? Here we go. All right. So first thing, let's talk about angle measure. Okay, parts of an angle. So let's draw this. Draw this 90 degrees, 180 degrees, all the way around. We go all the way around to, obviously, right, you know, all the way around 360, right? So we can do this on the coordinate plane. We can make little angles here where we have the initial side here and then the terminal side, and we'll explain that in a bit. But go ahead and draw that out. You guys have that drawn by now. So different parts of an angle. Okay, So we're going to start an angle here. We're going to call this side of the angle the initial side. And then this part that opens up, we call that the terminal side. This angle is in standard position because the initial side is at 0 degrees. That way we could start measuring it, right? So this angle is bigger than 90 degrees, smaller than 180 degrees, based on the coordinate resume. All right. So, okay, number 5 on your assignment. Draw an angle with a given measure in standard position. Okay, so draw an angle that's 110 degrees. All right, that's pretty straightforward. You don't need to do exact. You don't need to get your protractor and draw it exact. So 110 is going to be a little bit bigger than 90. So all you got to do is just go, okay, whoop, I don't know, approximately like that. Something like that. 110 degrees, that's all you've got to do. 110 degrees. That's all you've got to do. Now, number 7 asks you to draw an angle negative 900 degrees. Now, as we said before, this is the positive direction, right? That's the positive direction. So, the negative direction will be this way, right? You guys see that? Now, I know what you're saying to yourselves. Sensei, how can we go negative 900 degrees when the biggest we can do is 360 degrees? That would be negative 360, right? So, what are we going to do? What are you going to do? Well, we're going to keep spinning. Spinning, right? Here we go. Get my calculator here so I can make sure I get this right. Here we go. So I'm going to go here. Negative 900. How many degrees is that? 360. Let's keep going. How many degrees is that? 720. Negative 720. We're going the negative direction. How many more degrees do we need to go? 720, 80, 180 degrees, right? So, where would 180 degrees go? 180 degrees, you got to know 180 degrees? Negative 180, I'm going to go right here. And I will stop right there. If I was to take this, I spun it, and I spun it, and then it's going to end right here, and there's your angle. And you write negative 900 degrees to show that it spins, was that 2.5 times? 1, 2.5 times. And that's all you. All right. Let's see. Okay. So negative 900 would go here, here to here, right? Except we got to spin 1, 2.5. I think I did. So negative 900 degrees. All right. Coterminal angles. Definition. Write that down. Coterminal angles. 2 angles whose terminal sides coincide. That definition will knock you out of water. Coterminal angles. So who do I have here? Example. 80-degree angle and a 440-degree angle are coterminal. So let's draw the 80-degree angle first. 80-degree angle would be here, right? I go here, and it'd be probably right about there. There's my 80-degree angle. You guys with me? Now I'm going to draw my 440-degree angle. What color should I use? Blue. I will use blue. And I'm going to go like this. I'm going to start here on my initial side. And then, here we go. I'm going to go 360. What do I have to add to 360 to make it 440? 80 degrees. Yes. Tina, you're right. I'm going to add another 80 degrees. And it'll end right there. And that'll be my 440-degree angle. And those are my coterminal angles. Basically, to find coterminal angles, how do I find my, oh, that's 4, oh, shoot, that's embarrassing, I wrote it wrong. Caesar, why didn't you fix that? Do you still burn out on the test? Yeah. Okay, I accept that. 440 degrees. How would I find my next coterminal angle after 440? What would I do? Add 360 to 440, right? And you hit the next one. Or you could do, you could subtract 360, and you'll get the other coterminal angles, right? 360, 360, either direction. So let's take 80 degrees, and let's subtract 360 from 80 degrees, right? What does 80 take away 360? Or no, I'm using a calculator. That would be negative 280 degrees. So if I did another coterminal angle and I went in the negative direction, I'd go negative this way, bloop, and I'd have one at negative 280 degrees is another coterminal angle. I just subtract 360 from 80. And then I can subtract 360 from negative 280. Negative 280 minus 360. The next one would be negative 640. Negative 640, right? Spin it. Oh, Caesar. I can't talk and write at the same time. 640. And then I can subtract 360. And I can add 360. Boom, 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 boom. Get all the coterminal angles. Either add 360 or subtract 360. That's all you've got to do, right? Is this making sense? Anyhow, so, right, 440. What if I spun again? 800. Then you spin again, 1,160 degrees. Those are all coterminal angles. They're all right there. You just can't see them. Don't say anything if you're excited about this. Nice. Hey. No, hey. All right. So we can go in the negative direction. Obviously, that's what I was talking about. Negative 280, negative 640, negative 1,000, right? Just subtract 360. Those are all coterminal angles. So coterminal angles, not so bad, right? Has it gotten hard yet? Maybe. I don't know. Okay. Find one positive angle and one negative angle that is coterminal to negative 125 degrees. How do you find the positive angle? Add 360. So negative 125 degrees plus 360 degrees. What do you get? Plus 360. And I get 235 degrees. There's my positive. How do I get my negative? Subtract 360. 125 negative, take away 360, and I got negative 485 degrees. That's all you got to do. So far, so good. Can I flip it? Okay, 235, negative 485. Positive, add 360, negative, subtract 360. All right. Now let's talk about radians. So that's all I need to know for angles. Now we're going to talk about radians, not Rodon. Godzilla's enemy, which we should watch a Godzilla movie. Should we do karaoke again? Yes. I'm trying to think of a day. I got to ask the other teachers because it's disruptive. Huh? Instead of final. What the heck is a radian? I'll tell you. Let's go back to 5th grade math, my favorite subject.
3.
How do you solve for the circumference of a circle? Do you guys remember that? Yeah, very good, Chris. Yeah. It is not pi r squared. That's the area. Circumference is two things. Circumference, oh, by the way, let's review. From the center out, What do you call that? Radius. How about all the way across from the center, all the way through? What's that called? Diameter. How long is the radius compared to the diameter? The diameter is twice as big as the radius is half as big as the diameter, right? So this is twice as big as that, exactly. Two radiuses make one diameter. Are you guys with me? Anyhow, the circumference, you guys even know what circumference is? It's the length of the outside of the circle. If it was a regular shape, we'd call it a perimeter. But it's a circle, so we want to sound sexy. Hey, baby, you want to find the circumference, right? We don't say perimeter of the circle, we say circumference. It's the outside length. If you open it up and you measured it, that would be the circumference. Circumference is, by the way, do you guys know what pi is? Pi is approximately 3.14, right? You guys with me? Okay, so 3.14. The circumference is 2 times pi times the radius. So whatever the radius is, so let's say, for example, this radius is 5. Then the circumference will be 2 times pi times 5, which the most accurate way to write it would be 10 pi. Are you guys with me? But wait, there's more. Because circumference isn't just 2 times pi times the radius. There's another area for circumference. Circumference is also pi times the diameter. Whoa, how can I have a different formula? I thought it should be the same. Is that the same? What's 2 times r? Diameter. So, for example, if this is 5 and this diameter will be 10, this circumference will be 10 pi, right? Anyhow, let's take it up a notch, though. This is sort of Godzilla time. You don't need to write this down. You don't really need. I'm just trying to show you to understand something. If you don't memorize the circumference of the, you don't need to have the circumference of the circle memorized for the test. I don't think so. It's nice so we understand what's going on. Okay, circumference is pi times diameter, 2 pi times r. Now, let's solve for the circumference of this circle. Shall we? What's the circumference of this circle? Circumference is pi times diameter. Circumference is what? Or yours and my favorite singer. Thug Life. 2 pi. I don't even know this person's here. Oh, Louise. Oh, Louise. Oh. Oh. Did you even know? Oh, yeah. Okay. The distance around this circle is 2 pi. Are you guys with me there? Okay. What's the radius of this circle? 1. Very important that you understand this. We'll get into this in a bit. If we have a radius of 1, the circumference is 2 pi. What's this topic, by the way? Radians. Okay. I haven't got to radians yet, but let's talk about something else. Got about the circle, right? If we have a circumference of 1, if we have a radius of 1, the circumference is 2 pi. Bye, Louise. We'll miss you. Hey, I'm recording this. Did you hear me? Okay. You guys remember chemistry? Conversion factors. Do you guys remember if we have conversion factors? Like, do you guys know how, like, feet and inches are just different ways of measuring something, right? And if we have 1 foot, 12 inches are the same. So the conversion factor is going to be, like, say I want to convert inches into feet. Let's say I have 24 inches. Well, I got to multiply it by a conversion factor. What's my conversion factor going to be? Well, my conversion factor is whatever they're equal. 1 foot is equal to 12 inches. 12 inches is equal to 1 foot. Which one do I multiply it by? If I want to convert 24 inches into feet, which one do I use? Do I use A or B? Very good. A. I want to get rid of inches, so I put inches in the bottom, right? Because what happens? That cancels out, and I say 24 feet divided by 12, right? And what is 24 divided by 12? 2 feet. Who's that guy? What's going on? Oh, you go to class? Hey, all you guys. Ladies over there. Go to class. All right. So, if I wanted to say, hey, I want to convert, let's say, 3 feet into inches. Well, I got to find out there's 12 inches in 1 foot. That's my conversion factor. They're equal. I multiply it. What do I want to get rid of? The feet. So I put the feet on the bottom, right? And I put 12 inches on top because I want it to be inches. The feet cancel out, and it's 3 times 12. It's going to be 36 inches, right? Same thing with meters and centimeters. You have to figure out what's equal. So my conversion factor is going to be 1 meter over 100 centimeters or 100 centimeters over 1 meter, right? So if I had 500 centimeters, which one am I going to multiply it by? 1 meter is 100 centimeters, or 100 centimeters or 1 meter? Sorry, okay, yeah, sorry. Let's do it again. Thanks, Madison. A or B? A. Because I want to get rid of the centimeters, so I say 1 meter over 100 centimeters. The centimeters cancel out. It'll be 500 meters, because I got the meters still there, right? Divided by 100. And 500 divided by 100 is going to be what? 5 meters. So we understand how conversion factors work? You guys with me so far? Raise your hand if you understand how conversion factors work. Okay, cool. So, what are we talking about again? Radians. What have we talked about so far? Circumference of a circle and conversion factors. What's the circumference of a circle if my radius is 1? Think of your favorite singer. 2 pi. Thug life. Probably shouldn't say that on camera. And then conversion factors. Whatever you want to convert to, you put the whatever on the bottom, right? If I want to get rid of the feet, you put the feet on the bottom. If I want to get rid of inches, put inches on the bottom. If I want to get rid of centimeters, you put centimeters on the bottom, and so forth. Okay. Now, should we do this? How many centimeters are in 18 meters? Well, all you got to do is go, this 18 meters. What's my conversion factor? Well, I know there's 100 centimeters in a meter, so I say 1 meter over 100 centimeters, right? And then you cancel that out, it'll be 1,800 centimeters, right? Conversion factor. I hear you, Foo. Okay, so there you go. 1,800 centimeters. Okay. Now, we're going to try to put it all together. Why are we talking about this? Let's make a conversion factor. Okay. If this is 1, all right. How many degrees all the way around the circle? 360 degrees. If this is 1 unit, what's the circumference of this circle? Okay, if this radius is 1, what's the circumference of the circle? 2 pi. So can we say that this circle, 2 pi, is equal to 360 degrees as far as the distance goes? Can we say that?
Yeah.
Say yes. Just agree with me. Just play with me here, okay? Then, if I take this and I solve for pi, what should I do? Divide by 2. That cancels out. Pi equals 180 degrees. What is a radian? A radian is a different measurement that we can use to measure angles and circles instead of degrees. Radians to degrees is like inches to feet. Radians to degrees is like ounces to quarts. Radians to degrees is like millimeters to meters. It's just a different way of measuring angles. Now, our conversion factor is going to be pi radians is equal to 180 degrees. Write this down. Pi radians is equal to 180 degrees. So just like I asked you, hey, how many inches are in 3 feet? Or how many meters are in 1,000 centimeters? I'm going to ask you, how many degrees are these radians? Or how many radians are these degrees? That's basically what we're going to do. And based on all that, we're going to use this as our conversion factor. Pi radians equals 180 degrees. So our conversion factor is going to be pi over 180 degrees or 180 degrees over pi. The pi is just, once you see pi, you assume it's radians. For degrees, you got to put a little degree sign up there. Okay, those are our conversion factors. All right, you guys ready for some problems? Number 13. This is what we're going to be asked to do. Convert the degrees to measure radians. So you have 40 degrees. We want to convert that into radians. So let's do it here, shall we? 40 degrees. Here's my $1 million question, though. Should I use pi over 180 degrees, or should I use 180 degrees over pi? A or B? Raise your hand if you think it's A. Raise your hand if you think it's B. It's A. Because I want to change it to radians. I want to get rid of degrees. So you put degrees on the bottom. Or you can say this. I want it to be radians, so I put radians on top. Right? Ooh. Let's convert it, shall we? The degrees are going to cancel. That's kind of nice. 40 times pi, I'm going to do it the long way, is 40 pi over 180. Now, to write our answer completely, you must reduce your fraction completely to its simplest form. So this one's pretty straightforward. The zeros are going to cancel out. 4 pi over 18. And 4 and 18 are both divisible by what? 2. So our answer is going to be 2 pi over 9. 40 degrees is equal to 2 pi over 9 radians. And you don't need to write radians, you just need to write your answer like that. And that's all you've got to do. You have to make sure you know your conversion. Go ahead and do this one on your own. Negative 260 degrees, convert that to radians. See what you get. All right, negative 260 degrees. Class, negative 260 degrees. What do I multiply that by? I want to get rid of degrees. I put the degrees in the denominator. I want to change it to pi. I put pi in the numerator. Look at that, cancels out. The zeros cancel out. So it'll be negative 26 pi over 18. Both of those are divisible by 2, which will be negative 13 over 9. Negative 13 pi over 9. Completely reduced. Make sure if this is negative, then that's got to be negative also. But wait, there's more. Of course, we're going to have to change radians into degrees. So, what do you guys think? Number 17. Change pi over 9 radians into degrees. Pi over 9. Let's write it, homies. 180 degrees over pi, or pi over 180 degrees. Which one? A or B? Which one do you guys think it is? A. I want to get rid of the pi, right? Change it to degrees. Degrees is on top. 180 degrees over pi. Then you just go flocka, flocka. This one's a little bit easier. And just go 180 degrees over 9. So on your calculator, you do 180 divided by 9, or it's going to be 20 degrees, I believe, right? 20 degrees, because 180 divided by 9 is 20. And that's all you got to do. Oh, should I make this go around the class? Does anyone want to be on camera? It's illegal if I show you without your permission. I'll show you anyway. I don't care. I'm ready. Take this job. Oh, did I record that?